Here's the revised Fruitbowl. As you can see, it has a non-circular shape. The idea here was going to be that it can fit nicely to a wall and have an organic shape yet not be round, something I can't do on the lathe. And you can see it's made with layers, tiers, and they overlap. The way they overlap is by actually cutting two sets of rings that can bridge the gap between each other. So simply put, this is the finished bowl in its shape, and if I move the timeline here, you'll see I've flattened it out into pieces that can be cut. We can go into manufacturing and generate G-code. These could be moved closer together. As the size of the bowl varies, this gap changes. Sometimes you may need to change it around a little bit. And you could also do this set out of one piece of wood and the second set out of a different kind of wood, and have a variated color, alternating colors in the bowl itself. So the movements that flatten it out can be backed out to the bowl to see the bowl itself. The bowl shape is a couple of things, I guess, while we're back here. This can totally be milled from the top on the CNC. It's a one-sided project, because what you can see in here, if we zoom in, you can see this inset step on the outside of each ring, except for the very last one. And the previous ring, the bigger ring, fits inside here. So they all fit together. They overlap a little bit. That makes it self-aligning, and it's relatively easy to put a little glue in there and make them fit tightly. So a couple things you can do. This is very parametrically driven, and so the size and shape and a whole lot of different things can be varied. Let's just put the bowl over here on the right side of the screen, and let's get the parameter table on the left side of the screen here. Let's make it small enough that we can see what's going on here as we make changes. So some of these parameters are computed to be used in formulas within the features, and some of them are driving parameters that we put in. The basic size is the width of the centerpiece, and so this is 6 inches. You can see if I change this to 8 inches, then the whole bowl gets bigger. And back to 6 inches, and it gets smaller again. The base depth is computed, so the depth is from the front to the back here, and that's driven by a parameter called oval. That sort of sets this aspect ratio. So for example, if we go to 0.8, it gets a shape that's closer to round. I think 1 might be very close to round. So you can alter the shape to fit what you like. The concavity here refers to this shape along the almost straight edge. It can be concave. So for example, if this is 0.6, you see that it's approaching round. If this is 0.9, then you see that this shape actually becomes a little bit concave. If we make this 0.95, it starts to become almost like a heart shape, inverted in this case. The sizes of the tiers and how they fit together are driven by the tier width and a growth factor. The tiers vary in their width. As it goes up, the tiers typically get smaller, so that the rim of the bowl is thinner than the base of the bowl, the tiers at the base of the bowl. And that's the effect of tear growth. Again, you can play with these. Some of them may make it unmanufacturable, but that's what you'll find out. The parabolic factor changes this shape here. Instead of just a straight line, it actually curves out like you might turn a bowl a little bit. We can only do so much without needing, say, a third set of rings rather than just two sets of rings, because they end up on top of each other. We need enough gap between them for the end mill that cuts them out. Taper also affects the width of the rings. If we turn on the analysis here, let's look at a section of this, and let's pull this over to here so we can see this thing in cross section. If we change parameters like taper, you can see the rings get wider. In this case, it'll become unmanufacturable. With two sets of rings, it would require more, and some other weird artifacts are happening. So we'll just undo that change. Oops. What happened there? There we go. Undid the wrong change. Let's still some weird things happening here with how we've cut it. It's just an offset in where the cut is actually fine. Height tells us the overall height. This is computed based on the formulas that drive the shapes. Inset is the depth of overlap, the vertical overlap between rings. Chamfer, there's a chamfer, a 45-degree chamfer on here, and we can set how aggressive that chamfer is going to be. Currently set it at 3/16. And pointy and rounded, let's just zoom back out. Let's turn off the analysis. And actually, let's go back to something a little closer to what I had before on oval. Wrong direction. And let's have a look at this, and let's change the concavity as well back to, say, 0.8. Now, that's a little more similar to the shape of the pictures you've seen on the forum. And one last dimension that we can mess around with is called roundness. And this basically affects the shape of the curves that drive this. So right now, roundness is 3. If, for example, we made roundness 5, you would see the shape gets more pointy, actually, if you will. And if we change it to 2, they get almost round. In this case, I settled on 3 for the shape I liked. That's the parametrically driven design. Again, there's a spot here where we see the design of the bowl, and then there's the layout of the rings. And one thing to check after you make changes is to make sure that, in fact, your end mill can fit in between. So in this case, they can't. It looks like they overlap. So there's an issue here. And you can also change parameters in this view and see the effect. So let's go from tier width 0.8 to 0.7. That opens it up a bit. Let's see the tier growth. 0.8. Is that going to get better or worse? That actually makes it worse. Let's go to 0.5. 7 on that as well. And we still have an unacceptable gap here. We went parabolic 9.5. Let's go 0.92. That'll flatten out the design a bit. Oops, it actually had an unintended consequence there. Let's go 0.96. We went the wrong way. Now it looks like we'd have enough room between the narrowest ones. Let's just measure from this edge to this edge. 0.173, I'm going to use a 0.125 end mill. So now I have parameters that work. And again, I'm going to go back, have a look, see if that shape is what I like. Any questions? Just reach out to me on the SDFWA forum.